Well, I'm making this little introductory video just to describe and give a little overview of the kinds of concepts you're going to see in Chapter 12. This chapter is jam-packed with lots of different kinds of physics, and I'd say most of it is physics that you've seen before, but it's going to be applied now to things that are turning or rotating or rolling. We call these things rigid bodies. They're things like wheels and spheres and disks and things like that. So rigid just means the object itself is not going to deform as it moves. And so I want to show you just a couple examples of things you might see. So here in this first figure, we're going to revisit Newton's second law. And we've done problems like this before. You might remember where we hung a couple of masses over a pulley and we calculated the acceleration that they would have and maybe how much tension force it would have. But here's what we're going to do now that make it a little different. We're going to give this pulley a significant amount of mass. We used to treat it as almost massless, so we could just ignore the effect of the pulley. But now we're going to find that it's going to take a fair amount of force just to move the pulley wheel itself. So we'll have the mass of a disk, for example, and the size of the disk. And then all three objects, both the block A and block B, as well as the disk, are going to have to be accelerated if we're going to move. So it's just a new way of doing Newton's second law. Along with doing that, we're going to introduce the concept of a torque. Torque is kind of the rotational analog to a force. So here's a person exerting a torque on a merry-go-round. And as the person pushes with a force here on the merry-go-round, it'll make it spin. Well, the interesting thing about torque is we could have just as much force without any torque at all if we were to change the direction of that push. So you might imagine that that person could be pushing straight towards the center of the merry-go-round, and that would result in no turning at all. So we'll get into the fine points of torque. Then we're going to revisit work and energy again. So instead of things sliding along a surface or sliding down a ramp, now we're going to have things rolling across a surface or down a ramp. So we'll be doing work and energy again, but we'll have some different expressions that we'll use for our rolling objects. We've seen things in equilibrium before, like a balance of forces, but now we're going to have a balance of forces and a balance of torques. So for future civil engineers, you'll take several classes in statics, because the idea of civil engineering is to design things that won't move, like bridges and roads and houses and other infrastructure. So if we have a situation like this, we might ask the question like, how much force are we going to need from this cable in order to balance the weight of this beam that's sticking out from the hinge? And then one of the last things we'll do in this unit is look at collisions again. But this time the collision is going to be a little different. So if we go back to this merry-go-round example, suppose instead of pushing on the merry-go-round, we had the person get a running start. So when we see it from above, here's the person with some initial speed that jumps onto the very edge of the merry-go-round. Well, can you picture what's going to happen? After that collision, the merry-go-round and the person will both be now spinning. So we have to know how to account for the spinning motion after the collision occurs. And this requires a concept known as angular momentum. So obviously you can tell just from the name that it's the angular analog to linear momentum, which is all the momentum we've ever discussed before. You may not even have known that there was another version of momentum. So just thought I'd give you a little bit of a taste of the different things you're going to see, and then you won't get too concerned when you get into the nitty-gritty details. That if you see the big picture and think about the kinds of problems we're going to solve, that helps you maybe stay motivated for why you're going to learn all of the little details. So I think that'll do it for now. And now on to the fine points of doing all these problems. Good luck.